An object older than the Earth is cutting through our solar system right now, moving with a precision that defies chance. Its chemistry has been untouched for over 7 billion years, and its path lines up perfectly to skim past 3 planets in sequence, something so rare it should never happen. Some scientists believe it's just a comet. Others aren't so sure. If it isn't, then what exactly is 3I Atlas, and why has it come here now? In the summer of 2025, astronomers around the world noticed something unusual in the data streaming from a small observatory in Chile. At first glance, it was nothing more than a faint speck of light, but that speck was moving in a way no ordinary comet ever had. The detection came from the Atlas Survey, a project designed to find dangerous asteroids before they find us. But instead of a potential Earth impactor, the system flagged an object moving too fast to belong here. Within hours, orbital models revealed a stunning truth. This visitor was not from our solar system at all. It was officially designated 3I Atlas, the 3I meaning third interstellar object ever recorded, and Atlas for the telescope that spotted it. But the deeper scientists looked, the stranger it became. Its trajectory wasn't random, as one might expect from a body wandering in from deep space. It was unusually aligned with Earth's path around the Sun, as if it had slipped into our neighborhood through the exact plane our planets occupy. And that wasn't the only coincidence. Its route would carry it past Venus, then Mars, then Jupiter, in a precise sequence so rare, the odds have been calculated at 1 in 20,000. The timing of these passes wasn't just remarkable, it was suspiciously perfect. Then came the physical data. Spectral readings hinted at ancient water ice, organic molecules, and a faint, shimmering coma, the halo of gas and dust that surrounds active comets. But the coma was forming far too far from the Sun, and the tail, pointing toward the Sun instead of away from it. That's when Avi Loeb, Harvard astrophysicist and no stranger to controversy, stepped forward. In interviews and early papers, he suggested the unthinkable. Perhaps 3I Atlas wasn't a comet at all, but something made. This bold claim ignited both excitement and skepticism.
And when it gets closest to the Sun, the Earth would be on the opposite side, so we can't observe it. That could be on purpose if it wants to do some maneuver, taking advantage of the Sun's gravity or sending probes to the inner planets. So it looks quite unusual. It came from a direction where there are lots of stars in the sky. That's why we had a hard time identifying it. The question is it technological?
To most scientists, the idea of alien technology passing silently through our solar system still sounds like science fiction. And yet, the numbers, the path, and the timing all defy easy explanation. In the days that followed, the quiet observatory detection transformed into an international astronomical pursuit. From Hawaii to Chile, from space-based telescopes to the most advanced observatories on Earth, 3I Atlas became the single most watched object in the sky. And as the data poured in, one thing became clear. This is not just another comet. This is a once-in-a-lifetime opportunity to study an untouched fragment of the galaxy's ancient past, or perhaps to encounter something far more extraordinary. For most of human history, the very idea of an object from beyond our sun's influence was little more than theory. Astronomers knew the galaxy was filled with wandering debris, rocks, ice, dust, even planet-sized worlds drifting in the darkness between stars. But for centuries, none had ever been seen passing through our solar system. The assumption was simple. If such visitors did exist, they would be so rare that no living human would ever witness one. Perhaps one every few thousand years, perhaps never. That assumption died in October 2017. It was then that astronomers in Hawaii detected something strange moving across the sky. It was long, thin, and accelerating. It showed no comet-like tail, no obvious outgassing, nothing to explain why it was speeding up as it left the sun's gravity. They named it One-Eye Oumuamua, Hawaiian for a messenger from afar arriving first. Oumuamua shattered our sense of cosmic isolation. It was the first confirmed interstellar object, an alien rock born around another star, now cutting through our system before vanishing forever. Its origin remains a mystery. Some think it was a fragment from a shattered world. Others believe it might have been something far stranger, possibly even engineered. Just 2 years later, in August 2019, another visitor arrived, 2-Eye Borisov, discovered by amateur astronomer Gennady Borisov. This one was unmistakably a comet, its brilliant tail stretching thousands of kilometers into space. Its chemistry unlike any comet we had ever analyzed. Borisov was fast, volatile, and beautiful, a frozen relic from an entirely different planetary system. For scientists, 2 interstellar objects in just 2 years was shocking. It suggested something had changed, either in our ability to detect them or in the galaxy itself. Then, silence. No new interstellar objects were found for nearly 6 years. Search programs expanded, telescopes became more sensitive, but the skies offered no new messengers from beyond. It began to seem as though Oumuamua and Borisov were just rare flukes, anomalies we'd been lucky to catch, until July 1st, 2025. That was the day a faint, fast-moving point of light appeared in the data from Chile's Atlas survey. In hours, the calculations revealed something extraordinary. This was not from around here. It was inbound from far beyond the sun's reach, traveling on a one-way path through our solar system. Its designation, 3-Eye Atlas. But unlike its predecessors, 3-Eye Atlas would turn out to be larger, older, and far stranger than anyone expected. And, as we'll see, its arrival may not be a coincidence at all. The story begins on a cold, clear night in the Chilean Andes. At the Cerro Tololo Inter-American Observatory, the Atlas survey was quietly scanning the sky for potential threats, asteroids that could one day collide with Earth. Atlas works by taking rapid, wide-field images of the night sky, looking for moving points of light. Most of the time, it finds near-Earth objects or harmless asteroids within our solar system. But on July 1st, 2025, one detection didn't fit. A faint speck appeared, barely visible against the starfield, but moving too quickly for any known asteroid. Within hours, the automated system flagged it. The object's velocity was nearly 60 kilometers per second relative to the Sun. Too fast to be gravitationally bound to our star. Too fast to be a local resident of our cosmic neighborhood. When the coordinates and motion were plugged into orbital models, the conclusion was immediate and unmistakable. This was interstellar. It wasn't born here, and it would never return. Even more intriguing was the origin point. Its inbound path traced back toward the constellation Sagittarius, a dense, chaotic region near the center of the Milky Way. Sagittarius is one of the hardest parts of the sky to observe, flooded with background starlight, clouds of dust, and streams of radiation. That means 3-Eye Atlas could have been approaching for years, and we simply never saw it coming. And by the time we did, it was already inside the orbit of Jupiter, racing sunward. As astronomers refined the trajectory, more unusual details emerged. The object's orbit was retrograde, moving against the flow of the planets, which is expected for interstellar visitors. But the inclination was shockingly low, just 5 degrees off the ecliptic plane, almost matching the flat disk in which our planets orbit. Its path would take it past Venus, Mars, and Jupiter in a neat, linear sequence. The statistical odds of such a route occurring by chance, roughly 1 in 20,000. The discovery sent ripples through the astronomical community. If 3I Atlas was just another comet, it was behaving in ways we had never seen before. And then came the first hint that something truly strange was happening. Even at over 4 astronomical units from the Sun, more than 600 million kilometers away, the object was already active. It had developed a coma, a glowing halo of gas and dust, far earlier than most comets ever do. But the strangest part? The tail wasn't pointing away from the Sun, as solar radiation normally forces it to. It was pointing toward the Sun. The only way this makes sense is if the dust particles were unusually large and heavy, massive enough to resist the push of solar photons. And that was just the beginning of the surprises 3I Atlas had in store. From the very first orbital calculations, 3I Atlas refused to fit the mold. Yes, its retrograde motion, traveling opposite to the planets, was what astronomers expect from most interstellar visitors, but the angle of that motion was shockingly low, just 5 degrees off the ecliptic. That's almost perfectly in line with the flat plane in which all our planets orbit. Most interstellar objects slice into our solar system from steep, random angles. They arrive like stones thrown into a spinning frisbee, cutting across, not along, the disk. But 3I Atlas is different. It's gliding into the system as if it knows the layout. And then there's the planetary flyby sequence. Its path will carry it past Venus, then Mars, then Jupiter, in exactly that order. For a random, unbound object, the probability of such a sequence is astronomically low, estimated at 1 in 20,000. Yet 3I Atlas will hit those marks with perfect timing. Some scientists shrug and say it's a coincidence. Others aren't convinced. The object's coma adds another layer of mystery. Comets form these glowing halos of gas and dust when sunlight heats their icy surfaces, causing the ice to vaporize. But 3I Atlas began forming its coma far beyond the range where sunlight should have been strong enough, at over 4 astronomical units from the Sun. And the tail? It's not streaming away from the Sun as physics dictates. It's pointing toward it. The only explanation that fits the data is that its dust particles are unusually large and heavy, too massive for sunlight to push. This is not normal comet behavior. Then there's the matter of its speed and size. Initial measurements suggested it might be small, under a kilometer across. But high-resolution photometry has since revised that estimate upward, somewhere between 4 and 11 kilometers in diameter. If accurate, that makes 3I Atlas the largest interstellar object ever observed. Larger means brighter. Brighter means easier to track. And easier to track means more opportunities to learn, if we can keep it in view, because as strange as its orbit and physical behavior already are, the most important revelations about 3I Atlas would come when scientists began to break down what it's made of. When the first spectroscopic data arrived from Earth's largest telescopes, astronomers were expecting a chemical fingerprint similar to other comets. Instead, what they found added yet another layer to the mystery. Using instruments from the Gemini South Observatory in Chile, NASA's Infrared Telescope Facility in Hawaii, and space-based observatories like Hubble and the James Webb Space Telescope, scientists began to separate the light from 3I Atlas into its component wavelengths, revealing the secrets locked inside its icy surface. The signature was unmistakable: water ice, but not just any ice. This was pristine, untouched since the moment it formed. Organic molecules, complex carbon compounds that on Earth are associated with the chemistry of life. Silicates, minerals formed in the heat of stellar environments, and carbon-rich material unlike anything found in most local comets. These ingredients themselves aren't shocking. Many comets contain some or all of them. What is shocking is their state of preservation. Every molecule, every mineral in 3I Atlas appears unaltered since its birth. The age estimates are staggering, over 7 billion years old. That means this object formed before our sun even existed. It's older than the Earth, older than our entire solar system. Orbital backtracking suggests it may have originated in the thick disk of the Milky Way, a region populated by ancient stars and primordial debris left over from the galaxy's earliest days. This is not the same neighborhood where our solar system was born. It's a far older, quieter corner of the galaxy, a place largely cut off from the chaos of star formation. If true, then 3I Atlas is a time capsule, a frozen relic from an era when the Milky Way was young, a fragment of a long-dead planetary system cast adrift into interstellar space, now drifting through ours by sheer chance or by design. Its size adds to the significance. Revised measurements from high-resolution photometry suggest a nucleus between 4 and 11 kilometers across. That would make it not only the largest interstellar object we've ever detected, but also one of the most chemically pristine bodies ever studied. For planetary scientists, the chance to study something like this up close is unprecedented, and yet, even with the world's most powerful telescopes pointed at it, there's one major obstacle. In just a few months, 3I Atlas will slip behind the sun, out of our reach during the most active phase of its journey. And that leads us to the next challenge. For once, humanity had spotted an interstellar visitor early enough to study it in detail. But there's a problem, and it's a big one. When 3I Atlas reaches perihelion, its closest approach to the sun, it will be positioned directly behind the sun from Earth's perspective. For weeks, ground-based telescopes will be blind to it. This blackout will happen during the object's most active phase, when sunlight is heating its surface and driving the most dramatic outgassing events. The very moment we most want to observe. In astronomy, timing is everything, and this timing couldn't be worse. But there is a narrow window of opportunity. 2 spacecraft, each on unrelated missions, will be in the right place at the right time. The European Space Agency's JUICE mission, on its way to study Jupiter's icy moons, will pass within about 0.3 astronomical units of 3I Atlas during the blackout. That's roughly 45 million kilometers, close by cosmic standards. At the same time, NASA's Psyche mission, en route to the metal-rich asteroid Psyche in the main asteroid belt, will also pass within 0.4 astronomical units of the interstellar object. Neither mission was designed to study something like 3I Atlas, but with quick planning, both could turn their instruments toward it and capture data no Earth-based observatory could hope to get during the blackout. If either spacecraft seizes the opportunity, we might obtain high-resolution images, spectral scans, and perhaps even measurements of the mysterious tail and coma from an angle we've never had before. Opportunities like this are rare. In the case of Oumuamua, we had no chance to prepare. With Borisov, only weeks to act. But with 3I Atlas, the timing, despite the sun's interference, might finally allow us to study an interstellar visitor up close, in real time, as it passes through our solar system. And yet, some scientists argue that even if we get the perfect data, it may raise more questions than it answers, especially when we consider the theories about what this object might truly be. From the moment its trajectory was mapped, 3I Atlas has drawn the attention of one of astronomy's most outspoken figures, Avi Loeb, Harvard astrophysicist and no stranger to controversy, Loeb has a history with interstellar mysteries. When Oumuamua appeared in 2017, he famously suggested that its unexplained acceleration could be the result of artificial propulsion, perhaps even a light sail from another civilization. It was a theory that split the scientific community and thrust him into the spotlight. Now, with 3I Atlas, Loeb sees a new puzzle and some unsettling similarities. He points to 3 features in particular. 1. The shallow inclination, just 5 degrees off the ecliptic, almost as if it chose the same flat plane the planets occupy. 2. The planetary flyby sequence, Venus, Mars, Jupiter, an improbably perfect path. 3rd, potential non-gravitational accelerations, subtle deviations in speed or direction that can't be explained by gravity alone. In Loeb's view, these could be the hallmarks of something engineered, not formed by chance. In an early, non-peer-reviewed paper, he even suggested 3I Atlas could be a probe, and in the most speculative scenario, a hostile one. The response from the mainstream scientific community has been swift and skeptical. Most experts argue that every unusual feature of 3I Atlas can still be explained by natural processes, from its strange tail to its orbital path. They point out that comets are notoriously unpredictable, and that statistical outliers are bound to happen when you study enough of them. But the debate refuses to die, because this isn't just about one object, it's about a pattern. In the first 4 centuries of telescopic astronomy, we saw 0 interstellar visitors. In the last 8 years, we've seen 3, all detected late, all on strange paths, and all vanishing before we could get the answers we really wanted. Some researchers quietly wonder if we're looking at random chance or something else. Are we detecting more simply because our instruments have improved? Or has something in our galactic neighborhood changed? A gravitational shift, a denser region of space, a new stream of material being pushed our way? And then comes the most unsettling question of all. What if these aren't random visitors? What if we're only seeing the ones that want to be seen? It's a question without an answer, but 3I Atlas might be our best chance yet to find one, if we can study it long enough, and if its secrets are meant to be found. In science, one discovery can be an anomaly, 2 might be coincidence, but 3, all within the span of less than a decade, begins to look like a pattern. Before 2017, astronomers had never confirmed a single interstellar object. We knew they must exist, fragments cast adrift when planets form or when stars die. But the odds of one crossing our exact patch of space during our brief moment in history seemed impossibly small. Then came one, Oumuamua, silent and inexplicable. Then 2I Borisov, brilliant and clearly cometary. Now 3I Atlas, larger, older, and stranger than either of its predecessors. 3 visitors, 8 years, all detected late, all slipping into the solar system through observational blind spots. Some scientists see this as a triumph of technology. Our surveys have improved. Our sky coverage is better. The Atlas Project, Pan-STARRS, the upcoming Vera Rubin Observatory, all are scanning deeper and faster than ever before. It makes sense, they argue, that we'd simply find more now. But others aren't so sure. If our detection capabilities alone were responsible, we would expect these objects to arrive from random directions, with random inclinations, and at unpredictable intervals. Instead, there's a strange clustering, and 3I Atlas's shallow inclination, almost in the planetary plane, only deepens the suspicion. There are more unsettling possibilities. One is that our solar system may be drifting into a denser region of the galaxy, an area with more debris, more loose comets and asteroids from distant systems. Galactic dynamics aren't static. The Milky Way is full of stellar streams, shock waves from supernovae, and gravitational currents that can nudge vast clouds of material into new orbits. Another possibility: stellar encounters. Over millions of years, passing stars can subtly distort the orbits of objects in the galaxy's outer reaches, sending a rain of material inward. If such a disturbance occurred relatively recently, it could explain a temporary spike in interstellar traffic. And then, there's the theory no one likes to say aloud, that this isn't natural at all, that the timing, the alignments, the sequences, and the fact we've spotted 3 in rapid succession are not coincidence. Of course, the data doesn't point to an invasion. There's no evidence these objects pose any threat. But the universe doesn't need to be hostile for it to be unsettling. It's enough to know that space is far less empty than we once believed. And with each new visitor, the question grows louder. Are these truly random messengers from the stars? Or is there a reason they're arriving now? The answer might lie in what 3I Atlas is carrying, a preserved fragment of the galaxy's ancient past, now passing through our present. 3I Atlas is more than just another comet passing through the solar system. It's a messenger from a time before our sun was even born, a frozen witness to events older than the Earth itself. In its dust are the signatures of ancient stars. In its ice, the chemistry of worlds that have long since vanished. It moves with a precision that challenges probability and a beauty that defies explanation. Soon it will be gone. It will slip behind the sun, vanish into the outer darkness, and eventually return to the interstellar void from which it came. We'll have terabytes of data, spectral maps, and high-resolution images, and still, the central question will remain: what exactly was it? A relic of the galaxy's youth, wandering alone for billions of years, or a creation sent with a purpose we cannot yet guess? The truth is, our instruments, our telescopes, even our understanding, are not yet powerful enough to give us a definitive answer. But with each visitor, we move closer. 3I Atlas is a reminder that the universe is older than us, stranger than us, and perhaps not as silent as we once believed. So the next time you look up at the night sky, remember, something out there is moving toward us right now. The only question is, will we see it in time? If you want to keep watching the sky with me, stay tuned, because what's coming next might change everything we think we know.